Hi guys, we are still in chapter 4. Today is lesson 3, multiplying and dividing monomials. So a monomial is an algebraic expression consisting of one term. That one term can be either a number, a variable, or a product of a number or a variable or multiple numbers and variables. The example is right there for you. So in order for us to multiply monomials successfully, we need to know some rules. And the first rules of exponents is called a product rule. The product rule says when you multiply the same base, you simply add their exponents and the base stays the same. So again, we keep the base the same and add the exponents of both bases. So in the first example, x to the negative 6 times x. Let's see, I see x, which is the same base, and also please notice that it's x to what power? I'm going to write that in, x to the first power. Okay, so we're going to keep our x the same and add the exponents. Negative 6 plus 1 equals 2. So we're keeping the base the same. And negative 6 plus 1 is negative 5. And so remember that I would like to rewrite this using positive exponents. So I simply have to take a reciprocal of it. And let's take a look how it's going to look. So it's going to be 1 over x to the 5th power. Remember from last lesson, in order to write your negative exponent as a positive one, you have to take a reciprocal of it. And the exponent becomes positive. Let's take a look at the second example. I do see we have coefficients, negative 10 and positive 5. So the rule is we're going to multiply the coefficients and then multiply the same base, keeping the base the same and adding the exponents. So negative 10 times 5 is going to be negative 50. And then n base stays the same and it's going to be 7 plus 2. And we're going to write our answer right here, and that's going to be negative 50 and raised to the 9th power. And that's your final answer. Okay, moving on to example number 3. And example number 4, please pause me, do these on your own, and then compare the answers. Negative 5r to the negative 10th power, so I'm going to multiply the coefficients. Negative 5 times 3 is negative 15. And then base stays the same, and it's going to be negative 10 plus positive 6. And let's see, negative 15r, negative 10 plus 6 is negative 4. And my exponent is negative, so therefore I'm going to bring it to the bottom. I'm going to take a reciprocal again. Remember, fraction bar, don't do that. Fraction bar, what stays at the top? Let's see, negative 4 belongs to base r, so therefore negative 15 will stay at the top. And r to the negative 4th will go to the bottom and become positive exponent. So it will be negative 15 over r to the 4th. Example number 4, negative 2 times 7 is going to be negative 14. And then we're going to have a to the 1st times a to the 4th. So a stays 1 plus 4. And then b, 3 plus, remember this is 1. So b is 3 plus 1. My final answer is negative 14. A, 1 plus 4 is 5. And b, 3 plus 1 is 4. So negative 14, a to the 5th, b to the 4th. The next rule that I would like to talk to you about is called a quotient rule. And quotient rule says if you divide the same base, you simply subtract the exponents. And you subtract top exponent minus the bottom exponent. So please be careful here. Now let's take a look. Base stays the same. X is my base. It's the same. So it's going to be top exponent minus, and the bottom exponent is 3. So I'm just going to write that in. Base stays the same. Base stays the same. negative 4, and then remember we're going to do keep, change, change, keep, change, change, and it's going to be x raised to the negative 7th power. Now exponent is negative, so I'm going to rewrite my final answer using positive exponent. Remember, over 1 over x to the 7th power. Example number 6. Please be careful in this one. Base stays the same. Negative 7 top minus the bottom. Notice negative 7 minus, and then the bottom is negative 9. And then we have to do keep, change, change, right? So this is going to be y, base stays, raised to the 2nd power, and that's positive. So that would be my final answer. In example number 7, we have 2 bases, so that we're just going to do them one at a time. X, 7 minus 2, and then y, negative 2 minus negative 8. Please write them out because we do tend to make silly mistakes in this one. So base stays, 7 minus 2 is 5, and then y, negative 2, keep, change, change, to the 6th power. Both of them are positive, so that is my final answer. In this example, 12y to the 6th, 12 and 4. Can you reduce the coefficients? Yes, you can. So that's going to be 3. And then base stays, y, and then 6 minus negative 10. And then we're going to do keep, change, change. So your final answer would be 3 y to the 16th power. 3 times y to the 16th power. Final rule is called a power rule. And the power rule says whenever you raise a base that is already raised to a certain power to another power, you have to multiply the exponents. I say power to power is superpower, right? Because multiplication is way more powerful than addition, and therefore it becomes a superpower. So you multiply the exponents, okay? So you're not adding, you're multiplying the exponents. In the first example, now I need you to be paying attention very carefully. This exponent of 2, remember, it belongs to every factor on the inside of the parentheses, every single factor. So it's 4 raised to the 2nd power times b to the 3rd raised to the 2nd power, okay? And we're just going to simplify these. 4 to the 2nd is 16, and then b to the 3rd to the 2nd, power to power, superpower. 3 times 2 is 6, so b, the base stays, and then you multiply the exponent. So your final answer is 16b to the 6th power. Example number 10. Example number 10, we're going to do the same thing. We're going to raise negative 5 to the 3rd power, and then x to the 3rd power, ladies and gentlemen. So negative 5 to the 3rd power is negative 5 times negative 5 times negative 5, which is negative 125. And then 3 times 3 is 9, so it will be x to the 9th power. And that is my final answer. You guys, so what I'm going to do, I'm going to show you 2 more examples. They are not on that piece of paper that you printed out. So just copy this down in addition in your notes. And this example is on, just like on your Khan Academy. It's very similar to your Khan Academy ones. So I just wanted to do these because I just don't want you to be lost when you're completing your Khan Academy exercises. So first we're going to take a look at raising to negative exponents, raising factors to negative exponents. And remember, the same rule, power rule, applies. We're going to raise 4 to the 2nd to the negative 5th power times x to the negative 3rd power. Okay, going to be raised to the negative 5th power. Okay, so power to power, superpower, right? So we're just going to, first we're going to multiply the exponents, and then we're going to rewrite everything using positive exponents. So 4 stays. 2 times negative 5 is negative 10. And then times x, negative 3 times negative 5 is positive 15. Integer rules apply. And ladies and gentlemen, I have negative 10th, so I have to take a reciprocal of that, right? So your final answer will be x to the 15th stays at the top where it is, and then you take a reciprocal of 4 to the negative 10th. So it'll be 4 to the 10th power, and that will become positive, and that would be your final answer. Oops. Okay, last example. Let's take a look at quotients. So it would be 4 to the 2nd power over x to the 3rd power, and everything is raised to the negative 2nd power. Okay, so again, remember this exponent, it applies to top and bottom of this fraction. So it would be 4 to the 2nd to the negative 2nd over x to the 3rd raised to the negative 2nd power. Okay. So let's take a look here. 4 to the negative 4th power over x to the negative 6th power. Ladies and gentlemen, they're both negative, so we have to take a reciprocal of both. Or if you can notice this, we're simply going to just flip our fraction, and all the exponents right away will become positive. So it would be x to the 6th over 4 to the 4th power, and that would be your final answer. Hopefully this was not too bad. Email me if you have any questions, and I'll see you in the next lesson.